Okay, welcome to a lesson on compound probability. On your notes page, fill in these notes as we go. First, we have compound events. These are events that are made up of two or more events happening at once. Imagine the probability of a couple things happening at once or one after another. That's called a compound event. So for example, the probability that you would wear a hat and your favorite shoes the same day. It's kind of two events going on at once. Compound events can be made up of independent or dependent events. These are two of the most important words in probability. Let's make sure we understand them through the examples that are coming up. At any time, pause to think about what we're talking about or to take notes if it's moving too fast. All right, so let's begin with independent events. These are events where the outcome of one event does not affect the possible outcome of the other. For example, me being late to school and it raining that day. These two events are not, one does not affect the other. For example, if I'm late to school or if I'm not late to school, that does not change the probability that it will rain that day. So these two events do not influence one another. To find the probability of compound independent events, so events like this, all you do is multiply the probabilities of the individual events. And we did that with the AND rule the other day. So you just multiply one probability by the other and you get the probability of both of them happening. And you can see that works for 3 events, 4 events, however many you do in a row. Next we have dependent events. These are events where the outcome of one event does affect the possible outcome of the other. So dependent events is where one thing happens and it changes the probability that something else will happen. For example, amount of sleep you get one day, so the probability, let's say you go to bed really late, and then that will affect the probability that the next day you fall asleep in class. So if you go to sleep later, there's a higher probability you will sleep in class the next day. If you go to sleep earlier, there's a lower probability. So there's a dependence there. One affects the other. To get the probability of dependent events, which are also called conditional events, we use this formula. It's the same formula as the previous AND formula. You multiply one probability by the other, but here you see there's a B with that line and A. So that basically means the probability of B after A has occurred, because maybe A changed that probability. And to fill in those blanks, that symbol means the probability of B given A has occurred. So that means probability of B given A has occurred. All right, think about that notation. Let's go on to the next bit. Okay, the example we have is in a pencil case, there are 5 blue pens and 2 red pens. You reach in, grab a pen, and pull it out. Then you put the pen back. So if you're putting the pen back, the bag or the pencil case does not change. The first time you pull it out, your probability is the same as the next time you pull out something. So it says you reach in again and pull out a pen the second time. Are these events independent or dependent? So does your probability the second time depend on what happened the first time? No, it doesn't, because you've replaced the pen and the pencil case is exactly as it when it began. So these are independent events. To find the probability that you draw a blue pen the first time and red pen the second time, we would do probability of blue then red, and we would just multiply probability of getting a blue times the probability of getting a red. These numbers are not going to appear, so just listen and write it down. The probability of getting a blue is 5 out of the total, which is 7, so 5 out of 7. And you multiply that by probability of red, which is 2 red out of 7 total pens. Multiply those two fractions, you will get your probability of blue and red. So 5 over 7 times 2 over 7, which is 10 over 49. We're going to use the same situation, but change it a little bit in number 2. In number 2, you reach in, grab a pen, pull it out, but this time you do not put the pen back. So the pencil case has changed after the first time you removed something. So these are definitely dependent events, because what you do the first time will change what's going to happen the second time, because the pen is not replaced. So we're looking for the probability you draw a blue pen and then a red pen. So again, it's probability blue, then red. This time we're going to use the dependent formula, which is probability of blue times probability of red, given that B has occurred. This time the probability of getting a blue is still the same, 5 out of 7 total. And the probability of getting a red has changed now. There's still 2 red pens in there, but there's not 7 pens remaining in there. There's only 6 pens remaining in there. So it's going to be 5 out of 7 times 2 over 6. So it changed to 2 over 6. It's really important you see that. And that will turn, when you multiply those, you get 10 over 42. Different probability because the second probability has changed. Make sure you understand those examples clearly before moving on. Okay, last thing we're going to look at is how to present compound events in 2 different ways. One way is a way you've seen already, which is called a 2-dimensional diagram. You've seen this one before. There's a coin and another coin. They're both tossed at the same time. And this 2D diagram shows you all the possible outcomes. You can see HH, HT, TT, TH. Those are 4 outcomes right there. This can be presented in 2-dimensional way. But what if 3 things happened at one time? If 3 things happened, it would be impossible to show them on a 2D grid because you can only show 1 event and a second event here. How can you show 3 events at one time? So the way to do that is to do a tree diagram, which looks like this. So here you can see 1 coin is tossed, a second coin, and then a third coin. So 3 events in a row are shown here. And you can see first it can be a heads or tail, then a head or tail from each of those, and then head or tail again. And this tree diagram leads you to all the possible outcomes on the right side. Okay, let's answer the problems to end it off here. Possible outcomes in this one. Possible outcomes are the 4 that you see on there. Those are all the things that could happen. You could get a head and a tail, a head, a tail head, or a tail tail. So how many possible outcomes? The answer to that is 4. And finally, what is the probability of getting A? It says 1 head only. So you look at your outcomes and you're like, which one of those represents only 1 head? If you look at that, those 2 outcomes which are circled represent 1 head only. So that's 2 of the outcomes out of the 4 meet that criteria. So that's 0.5. 3b says, what is the probability of getting at least 1 tail? So now you look at it again, and you're like, at least 1 tail. Well, I see 1 tail there. I see 1 tail there. But it says at least 1 tail. That means 2 tails is okay as well. So that's the third option right there. So 3 of the 4 meet this criteria, which is 0.75. Okay, again, pause if you need to really understand. And then let's look at the last example. Last example takes you back to the tree. And it says, in this tree, how many possible outcomes are there? So if you follow each of the branches, it leads you to all these possibilities. For example, on top there, you have head, 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 and then head, head, tail. So those are all your possible outcomes. And if you count them, you notice there are 8 possible outcomes for tossing 3 coins. What is the probability of getting 1 head only? So you look at that and you're like, which of those journeys along that tree diagram give me 1 head? So if I go like this, there's my 1 head. So now when I toss my second coin, I cannot get a head because I'm looking for 1 head only. So I go there, tail. I'm still looking for a journey that gives me only 1 head, so the third toss has to be a tail as well. So if you follow that path, you see it's head, tail, tail. So that's 1 head only. There's more paths that give you 1 head. For example, if you go tail on the first coin and then head on the second coin, so there's your 1 head. Now your third coin has to be a tail as well because that's 1 head only. See, tail, head, tail. And there's also another path that leads there as well. Can you see the third one? So if I go along the bottom again, tail, then tail again on the second toss, and the third coin gives me a head. So you can see that path gives me a tail, and then a head on the third toss. So that's also 1 head. So 1 head only, 3 paths get me there. That one, and that one. So that's 3 of the 8. Let's go back to that for a second. That disappeared too quickly. That's 3 of the 8. Let me go back to it right. Oh, did it again. All right, anyway, there it is. You can see it here. 3 of the 8 give you 1 head only. Convert that to a decimal for probability. Then find B and C as well. I'll come around and check how that went before you proceed with the rest of the assignment. Good luck.